Hi guys, welcome back for another video, and for today's video we're going to answer this given activity in this chapter, which is the chapter 4. So let's proceed. So for this activity entitled physical layer terminology, so we have the instructions. So it is descriptions of the physical layer are provided in the table. Drag each physical layer term to each description. So for the term, and the physical layer description for number 1 is media that uses patterns of microwaves to represent bits. So it is wireless because the wireless is it uses the microwave, and for this to able to connect for one device to another. The capacity of the medium to carry data. Bandwidth. It is the bandwidth because I think it is the bandwidth because bandwidth has the characteristic to minimize or maximize the capacity of a data. And for the next one is media that uses patterns of light to represent bits. So is fiber optic. It is fiber optic because of the term light. This fiber optic only enables by the patterns of light. Next, a measure of a transfer of bits across the media. It is the throughput. I read it earlier, so I'm pretty sure about my answer. The next one, media that uses electrical pulse to represent bits. It is the copper. Okay, we're now done for this first activity in this chapter 4. So let's check if our answers is correct. Okay, we have answered it correctly, so we can proceed to the next activity for this chapter. Okay, for this one, we have the activity copper media characteristics. So the instructions is UTP, STP, and coaxial copper media characteristics are provided in the table. Click the appropriate field to match the characteristics to the media type. So attaches antennas to wireless devices. Can be bundled with fiber optic cabling for two-way data transmission. So it is coaxial. Counters EMI and RFI by using shielding techniques and special connectors. We have STP for the common network media. It is obviously the UTP. And now terminates with B and C, N type and F type connectors. It is a coaxial. So that's it for this activity. We can check if our answer is correct. Let's proceed. And now the answer is correct. So let's proceed to another activity. Okay. So for this activity, we have the T586A cable pinouts. For the instruction is correctly align the wire collars to build a TIA and EIA 568A cable pinout. Drag each wire collar to its correct placement on the RJ45 image in the graphic. So we are going to drag each wire to its corresponding place. So for this, from this RJ45 connector T568A pin out, so I've seen it earlier, so we can start. We can start with this one. So I'm gonna make it a little bit faster because I've read this one earlier and I'm pretty sure of my answer. Okay, this is my answer, and let's check it out if we got it right. Okay, that's what I said earlier. I'm pretty sure about my answer because I've read this one. So we can proceed for the figure 2. Now it's a different cable. It is for the RJ45 T568B pin out. So same instruction. So let's proceed. Okay. For this, can we check this one if we got it right? Okay, let's check. And now we get it right. Now let's proceed to the next activity. This one. So for this activity, we have the fiber optics terminology, and for the instruction, the descriptions of fiber optic media are provided in the table. Click the appropriate field to match the description to the fiber optic cable type. So we have the multi-mode and the single mode. So let's answer this one, this activity. Let's proceed now. Can help data travel approximately 1.24 miles or 2 kilometer or 2000 meter. It is the multi-mode. Uses the light emitting diodes, LEDs as the data light source transmitter. So it is a multi-mode. Uses laser in a single stream as a data light source transmitter. It is the single mode. Use to connect long distance telephony and cable TV application. Single mode. Can travel approximately 62.5 miles or 100 km per 100,000 meter. It is the single mode. Uses within a campus network. It is the multi-mode. Okay, let's check our answer, and we have it correctly. We can proceed to our next activity. have this activity, the part 1 of this activity, generic frame. So for the instructions, drag the generic frame field to its correct location on the diagram, and let's proceed. So here we got header, the packet data. The packet data is always in the middle. The trailer, and we can proceed here. We begin with the frame start, then the addressing the types, and the control. We have the control here, and as I said earlier, the data center. We have this for the data, and the error detection, and lastly the frame stop. Okay, we can check our answer if we are correct. Okay, let's start. Okay, we get it right. Now we can go for the part 2, the figure 2 for this activity. Same instructions, so let's proceed. Contains the IP header, transport layer, PDU, and data. Data, we have data. Contains the IP header, it's the data. Identifies the layer 3 protocol used by LLC. Layer 3 protocol, identify for the type. Type, identify. Marks the end of the frame. Is the frame stop indicator flag. So identify source and destination host by MAC address. So we have the addressing, and specifies special flow control services. Control services, we have control. Now we can check our answer. Okay, we are correct. So that's it for this chapter 4 activities, and thank you for watching.